And also I open my presentation. Yeah, as I said, we are today we want to go from the once we have understood the current state, of course, then management is about the move to the future state. No, so that is the very simple general description of that. And we are talking about we call this water resources management, water system management, water resource system management. I think I like even better. But of course, the term management is also kind of broad. So we are here, of course, doing that in the framework of IWRM, and we are perhaps sometimes using terms like water resources planning or water resources development as well. So these are basically steps of IWRM or parts of IWRM. Okay, let me go also here a bit faster, and just a repetition. We have learned that water resources are unevenly distributed over space and over time. So that's the fundamental challenge we are facing. We also have increasing water stress. So that means the gap between availability and demand is increasing, especially in certain parts of the world. You can also look at additional challenges, like here a map on reduced runoff. So this is a result of the exercise to model future water resources. And you see in the place where you are, in Southern Africa, it is one of the regions where probably runoff or blue water availability, I have called it in another slide yesterday, is going to be reduced. There are regions that are hit worse by this, like Mediterranean region, Southern Europe, Northern Africa, Middle East. Also the Central America actually will be hit quite strongly by reduced water availability. In the recent report, you have a refined analysis using different scenarios. Here they have differentiated December, January, February. That means the northern globe winter or the southern globe summer. And then here you have June, July, August. And you see that depending on where you are in the world and which season you're looking at, there is a different response. But all the models say that Southern Africa, for example, is going to have a reduced runoff. This is even now the newest version, assessment report 6. I mentioned that. Please consult it, zoom into your region, or to try to find the right information about the sector you're interested in. It is a huge work. It is altogether 10,000 or more pages, but you have to target your part of the report. And here, these are just summary maps. The same for soil moisture. So if you look at modeling soil moisture, we also see that there will be quite drastic responses to climate change. Of course, soil moisture is a function also of temperature. Temperature is going to increase. It's already now the only parameter that is very sure to already have changed, temperature increase. And of course, even with the same precipitation, you will increase evapotranspiration, and with that reduce the soil moisture. Again, here you have more refined modeling, and again, of course, the same regions are affected also by a deficit in soil moisture. Now, an additional challenge, and now, we are still at the challenges. Is actually the demand for water. So the offer for water will be reduced, the demand for water will be increased. So and also the general pressure on water. So if you look at certain regions, here are selected regions of the world. The most populated one is actually East Asia, including China and the Pacific. You will see the growth is going to level. Whereas here in this brown line here is Sub-Saharan Africa, and you see how strong it will increase. So we are here now, and this is the projected future for 2050. In a similar way, also the increase here in the Middle East and Northern Africa. That is the second region that is going to face an extreme growth. Others, like here, Europe, for example, used to be the second most populous part of the world, but it's of course now, even in the future, going to decrease. Also, even Latin America is stabilizing, like East Asia. So many parts of the world are moving towards a stabilization of population, but most parts of Africa and the Middle East are going to have a strong increase. That means here we have the need to do more, because you want to not only make sure that the fraction of the population that does not have access to safe water now, or doesn't have safe sanitation now, or it doesn't have water security in general, that you want to reach. That is the challenge number one. In addition, there will be even more people. So it's a double challenge, because there is a current gap between the desired level of water security and the actual water security, but we have to consider that in 10 years and 20 years, there's even more people to be supplied. And of course, that is going in line with the economic growth, which is probably even stronger than the population growth. So what you see here is just the increased number of people, but if you add, let's say, economic growth that is in another order, perhaps 4, 5, 6%, then this has, of course, a much higher resulting water demand for water security. Yeah, we have, this is again a repetition. So if we then want to summarize the challenges coming from climate change, coming from demographic change, coming from economic change, then we simplify it by saying, okay, there are three major categories of it. And of course, we also said, okay, the goal is, of course, to cope with these challenges, and these goals are summarized in the SDGs. But as I said, it's an attempt to summarize the global or the general goals at a global scale. And SDG 6 is now the one that perhaps refers to many of the challenges I mentioned, not all of the challenges, because the challenge of supplying food to people would be the SDG 2. That is the food security goal, or the energy security goal is number 7. Then the water-related disasters you find in SDG goal 11, which is dealing with settlements and cities. But okay, it's sometimes difficult to say where exactly do you talk about coping with climate extremes. And that is actually in 11, and the actual climate goal is number 13. So you find many water issues being distributed over the different SDGs, but SDG 6 is exclusively dedicated to water. And of course, here you have the typical aspects that are related to supplying people with water, that is talking about sanitation and reducing pollution. You are talking about the ambient water quality, that means water quality in the environment. You are talking about efficient use of water. And then, of course, as I said, perhaps the most important one and a good justification, and probably it was the justification for this PhD program, the goal to, or the target to implement IWM, and last but not least, to protect water-related ecosystems. There is another SDG just on terrestrial ecosystems 15, but if it comes here to water-related ecosystems, it's allocated here. No? So again, there are things you should know about. Referring to SDGs nowadays is important. If you apply for funds, you should all usually say, okay, how do you support sustainable development? That means the SDGs, and you should know where to find what goal. But for our purpose, we said, okay, it is easy because we just have one goal. We are following one goal, and that is water security, because that is actually including all the goals that we are talking about. No? The drinking water and human well-being, that means supplying safe water, but in general also having sanitation systems that are reducing or hopefully eliminating waterborne diseases and are supporting human health and human well-being in general. You have all the reference here to the ecosystem. That means on one hand, we have to protect those ecosystems that provide us with a service of supplying fresh water of good quality. If you don't protect the source areas, and these could be source areas for rivers coming from typically mountains, it could be the source areas for water sources, no? So that is springs, for example, spring protection, and it could also be the source protection of areas that are recharging the groundwater. No? On the other hand, some ecosystems, they also demand fresh water. No? So that means certain wetlands, certain floodplains, certain basically forest ecosystems. They need water in order to continue living, no? And ecosystems, on the other hand, they are the foundation for biodiversity. They are the foundation for many other ecosystem services. So the supply of safe and secure water as such, no, providing water is one ecosystem service, but there are hundreds more. And if an ecosystem is running out of water, it cannot provide these ecosystems anymore. And first and foremost, to conserve biodiversity, if you think about all the different the challenges that we are facing, so you may sometimes say, okay, biodiversity, okay, we are humans, we count first, and then let's think about the creatures on Earth second. But in the long run, if we are eliminating more and more species, we will also not have the foundation to live anymore on this planet. So conserving biodiversity as such is also a very important task, and the Convention on Biodiversity, I think, was recently confirmed and is a very important global agenda. And then the other set of goals is related to water related hazards, and the hazards again are exacerbated by climate change. So that is, but also climate change, as I mentioned, it can have long-term effects. So that is obvious that we have to protect the population, that we have to create resilient water systems. And last but not least, but this is also a huge part of water security, is all the economic activities that depend on water need to be secured. And that is first and foremost agriculture. If it is supplied with water, we call it irrigation. But it's also food production in the later food production chain. It's energy production. It's all industries. It's transport, navigation, tourism. All kinds of. There's almost no energy. There's almost no industry branch that does not require water. So that is the concept of water security, and it's so in a nutshell, it's basically our goal. It's the goal of water management. Yeah, okay, we talked about climate change. Now, what is then water management? If we say water management is to reach these goals, of course, the goals are different from region to region. And so water management could mean different things for people in arid countries or in wet countries. It could also mean, regarding the glasses you wear, it could have another element to it. Of course, if you ask an engineer what is water resource management, then he would say, oh, building reservoirs, having infrastructure for flood protection, treating water, supplying water, treating wastewater, etc., etc. But an environmentalist would perhaps say, would refer to other aspects of water security. So depending on, let's say, where you come from, but also depending on the aspect of water security you are looking at, you will find different answers to what is water management. So we have introduced the term water governance, so that would be here the aspect of water management in the sense of legal and institutional terms, or even economic terms. And all that is true, all that is part of water management. So it is a combination of different activities. And again, I referred to a simple conceptual model that we are following here in this lecture. So understanding where we are now, that is, let's say, the assessment we have covered, and then somehow defining goals. We have at least done that at the, let's say, in a general way with the water security. Now, of course, for your system where you're working, you have to define the specific goals of that region. And in the previous slide, you could see that depending on each location, you may have different emphasis. And once you know the goal, then the big question is how to reach that. So that means we are formulating a plan and we look at interventions. And we are following here in this sense, of course, the system approach. And if you, let's say, want to read more about it, there's a very good book by Lux and von Beek. It's also openly available. It's called Water Resources, Water System Analysis and Management. And it's an open source book. As I said, Lux, I think he's still a professor in the United States, von Beek, I think, in the Netherlands, and they wrote this book together. I think a good introduction to managing water on the basis of water resources systems. And in let's say, in a way, it is going from this linear more to a circular point of view. And that means now that we are, of course, on one hand, we have more opportunities to refine the management in a continuous form, but it's also more challenging because it's showing us the complexity of the management process. And it's, of course, it needs to be integrated. So this is, I think, what you have already had an introduction to what is IWM, and we are typically looking at a combination of different technical or infrastructure related issues, considering the natural system, of course, which all its potential nature-based solutions nowadays are this big topic. But of course, also the institutional and the economic system are part of IWM. And okay, so then let's look at this again in a perhaps in a way that is easy to understand. That means we are going from the assessment, the water resources system today. Perhaps we are not so happy. Even the sun is not so happy, doesn't look so happy, to a future state where we and the nature and even the sun is happy. And this is what we call water security, the state of water security. And now, how do we get there? By defining a plan. That would be the first thing. Of course, later that plan needs to be implemented. But first, we have to have an idea how to go from A to B, how to go from the current state to the next state. And how do we do that? We are usually starting with an initial scoping. So that is now understanding where we are today. we are saying, okay, what are we going to talk about? No, and related to that is always the question, who is involved? Who is involved in, let's say, in the water resources systems today, and also on the way? That means during the plan, whom should we integrate? And that is often informed by the question, who should be involved tomorrow? That is the whole process of what we call participation or participatory water management, and that is of very high relevance. Of course, you could say anyone is involved because everyone is a water consumer, but here we talk rather about the institutions that are representing certain water consumers or water polluters, perhaps, water users, and they should be involved. And that is done at the very beginning, because it's too late if you say, okay, we can talk to them later. Perhaps later you have taken decisions, you have changed your system, and not everyone is really happy about that. So then we do, and this is wrong terminology here, not river basin inventory, but we use in this lecture the term the water resources baseline assessment. And then, of course, we have to define the goals. That means we have to solve the problems that we identified. And that is perhaps here it's the most obvious aspect of why it's important to involve people, in order to then say, once we agree on the goals, to define the measures. And we should define indicators. That means, how can we define success? A measure is something we want to do, but the goal, and that could be even let's say the goal in a form of a process, or the goal of the final status, needs to be defined. And here I introduced the idea of nominating certain variables as indicators that tell us really where we are. And that means we have to have a monitoring evaluation concept throughout our plan, and then say, on the way, when we implement it, we can say every couple of months or every couple of years, depending on the duration of your plan, you can evaluate it. And if and that means you are typically doing that with milestones. That's classical project management. If a milestone is not fulfilled, that means if the indicator is bad, you have to ask why, and you have to redesign your approach, and that is, let's say, the way of implementation and also readjustment of the activities. And you need certain tools. So tomorrow we will introduce some of the tools which are often related to data and information. Of course, if people should be involved, also issues like facilitation of change and knowledge management, for example. And data management is much more a kind of social question, because who has access to what data and who needs what data? How transparent is data management? All these are more, let's say, social and institutional issues rather than just technical issues. Technically, it can be solved, but often it is a question of data access, information sharing, that is the tougher question. Yeah, and you need these tools in different parts of the process. Yeah, that means now, okay, having said that, you can, of course, talk about the technical solution, but much more important is really to bring people on one table. That is the role of participation in water resources planning. Of course, now this looks like a planning process. This is a table where the water resources system is in front of everyone, and everyone can explain what is his or her demand, concern, problem, but also looking at the others at the same time, and looking at the whole system at the same time. So I think this is a nice visualization. I think this guy here, he's the scientist, so that would be us as academicians. We are analyzing it, providing the information so that the other stakeholders can take better decisions. Hopefully, that is our role. I don't know how you understand your role. At the moment, you are, of course, doing research, but probably your goal is to become a scientist, a teacher, perhaps. And of course, our role is to support the others, those that are taking the decisions at the end, in taking the right decisions. No, that means to help them understand the system in a complex and holistic form, but also providing them exactly the information they need to take better decisions. So that is, perhaps this is why I'm saying this at the beginning of the ideas what to do, because what to do, and this is also in the previous figure I've shown, that is to involve the right people and to make sure that those who have a stake in water resources management are involved. Now, before we talk about individual solutions, perhaps we can look at a more strategic approaches. No, that means we need to classify the interventions. Obviously, going from the current state to the to reach the goal, we can talk about the issues of too little water, water scarcity. If we identify that there is not enough water, we have in this figure we have three major options, which of course, again, if someone says there are four options and naming them, I think I would also not object. The word is not so singular that you can just say, okay, it's just these three options. But it makes sense for me also to say, okay, I can do the following. I can develop new water resources. So that is, of course, new water resources or developing water sounds a bit strange, because the water on our planet is limited. It's a certain amount of H2O molecules that we have. So you cannot create new water, in this sense. You cannot, but you can, let's say, in the sense of making it available in a certain part of the world at a certain time of the world. That's what we are talking about when we say developing water resources. So that means typically storage. So if we store water from a time where it is available abundantly, then and we store it, then we have created an additional water resource, for that place and for that time. So that's the idea here. And of course, you talk about then building a reservoir, making more water available. That's a classical approach. It's like a reflex almost. Okay, we need water. Yeah, then let's see, where do we have water? Let's bring it to that place somehow. That could be, of course, coming from the upstream, and you're collecting the water and making it available when you need it. There would be many other ways to provide more water. For example, just abstracting more groundwater. That is, of course, it's a solution, but then you have to think about the long-term viability of that solution. And there are many other ways to store water, not only building reservoirs, but we can store water in the ground as well. So that just converting some of the additional or extra surface flow, and finding a good place to infiltrate it, perhaps with the support of artificial aquifer recharge, injecting it into infiltration wells, or changing the surface in a part of the natural ecosystem in a way that infiltration is improved, and then recharging the groundwater. With that, of course, I reach a sustainable balance. If I abstract groundwater from the same aquifer, and I have an managed aquifer recharge or artificial groundwater recharge, then I reach a very good equilibrium that is providing more new water resources, developing water resources. Yeah, I can also use the water from drains, no? So that, I mean, I can use, I can treat wastewater. I can, let's say, that is also additional resources. Either you are just basically discharging it, the wastewater to the river and then to the, ultimately to the ocean. You can treat it and reuse it, for example. Then you have, okay, transbasin diversion. That is, of course, also an option. If you take water from other places, you are moving water from place A to place B. That's also developing water resources. And then the most, let's say, the other big option, especially in dry regions, and if you are close to the ocean, if you are very far from the ocean, it's going to be very costly because you have to build long pipelines. But if you are close to the ocean, desalination, of course, is a good option. It requires energy, but if you have energy and if you make the, let's say, the balance and you see, okay, it's worth it, then desalination is a good option. Cloud seeding, that is a bit, it used to be a certain fashion. It's functioning. That means if you have let's say in higher altitudes, you have a saturated atmosphere with water. It sometimes just needs, let's say, very small particles in order to start condensation. And that is, yeah, we call that supersaturated atmosphere, and then clouds are formed, and eventually they will rain down. So it's working, but of course it's not really. It will ultimately, of course, not change. It doesn't change the total amount of moisture that is available in the atmosphere. So it will rain less in other parts of the world. But it's if you know how to manage it, it's working. No? But I'm not sure if it's a sustainable way to manage the water cycle. And the virtual water. So virtual water is actually the closing the, instead of producing, let's say, the simple example could be you consume so and so many thousand tons of tomatoes. If you grow them in your own region, in your own country, you need so and so many millions of cubic meter of water for that. Instead, you could import it, and with that you are saving water. No, so that is in a certain way an additional water resource that you have if you import goods with a high water footprint. Then this is also a solution. And yeah, in this figure, they also differentiate between the larger scale. They call it here the state. It's not only state. No, I would say just at the large scale you can do certain things, and at the local scale you can do certain things. No, so that. But it's I think more the principle here. No, so if water scarcity is the problem you identify now, of course we could discuss. What is better, building a reservoir, or should I one big reservoir or many small reservoirs? Should I store the water rather in? That means, yeah, storage. Should I implement storage by storing water in the soil or in the groundwater, or should I store it in an open reservoir or in a pond, in many small ponds, perhaps? No, so that could be then that is then leading to the question that you identify the need for storage, yes, in order to supply water to the different users or the points of demand. But how to store it adequately, that would then be later a question of understanding the cost of any solution, the effectiveness of any solution, but also the side effects, the so-called external effects of it. And that could be external effects in the negative sense, but it could also be external effects in the positive sense. That could be what we also like to call co-benefits. No, so a certain solution like using the nature to infiltrate groundwater or to infiltrate excess surface water to the ground or excess rainwater to the ground could create nice ecosystems that have a high biodiversity, or that could even serve as recreational areas. No, so these are co-benefits we have to include in order to take the right decision. Okay, so that is category number one. Category number two is using water more efficiently. No? Not creating, not if you say we have too little water, you say, okay, then we need more water. That is perhaps the ultimate reflex. No, but it could also mean that we are just doing the same thing but using less water. So that is conserving water and making water use more efficiently. So here we can talk about, for example, no, if you have a open channel, you can line it, no, then you have less infiltration from the channel, you have less losses. Or converting it into pipe water, that would even then also reduce the evaporation from that channel. You can have a better dam management. With that, you are losing less water. You have a better operation of the reservoir or of the dam. You can have all kinds of water management practice, agriculture practices that are increasing water use efficiency. No, the awareness campaigns, because at the end, people are working in institutions or working on a farm or wherever. They are taking the day-to-day decisions on using more or less water, or using water in a different way. So creating awareness, doing capacity development alone would be a very important contribution to conserving water. But you could also introduce, of course, pricing. No, that means economic measures are usually quite effective in changing the behavior of people. It could be through awareness, saying, oh, I should save water. That is, for example, what happened in Germany. And even though we are not really a big, let's say, such a water scarce country, but still people said, oh, yeah, we should save water. There were campaigns, environmental awareness, and just because of that, people took a shorter shower, or they used water more, considerate in their household, and with that the total consumption per household was reduced significantly. But on the other hand also, and at the end you don't know exactly what is the biggest effect, but introducing a price to water has a similar effect. You know, if you have to pay for something, you think twice if you are wasting it or not. And of course, effective institutions, etc. So water use efficiency, conserving water is of course another category. And last but not least, you can say, okay, I have, without having new water resources, without using them more efficiently, I can change the form of allocation. No, I say, okay, those users that really require it, users that have a certain priority, they should get it, and others are getting less, of course. If one gets more, the other gets less. So that is, for example, I mentioned perhaps that we started with the IWM master course 2007 in Jordan, and since then continuously observing also the water sector there. And let's say it changed from having over 70% for agriculture in Jordan allocated to the sector to now around 50%. So there is a significant reallocation of water from agriculture to urban uses, and that is now okay. It can happen by prescription of the government. But it can also happen more or less by kind of economic development in general. But this is usually through quotas. You can steer that through water rights or markets. Water markets. You have heard, I think, good examples, but there are also bad examples, non-functional examples of water markets. And that is, let's say, perhaps the yeah, one of the best known markets is actually in Australia in the Murray-Darling Basin, where several droughts have hit that region, and they started to introduce a system that of course relies on a good infrastructure. It also relies on the way to on the need to monitor exact volumes of water. But once you have that, then you can start a market. You can say, yeah, user A, he can either water his tomatoes with water and then understand what is the benefit I get out of it, or he could sell it to the neighbor. The neighbor may produce more high value crops, and with that, or he has perhaps permanent agriculture. That means perhaps some trees, and the trees would die. So for the neighbor, the water has a much higher value, and then they are trading water, and with that reaching a higher overall efficiency. But also, of course, it requires that at the larger level, let's say the river basin level or the national level, you have institutions that are arranging that allocation or the reallocation. Yeah, so that is, let's say I could, of course, now we could go through examples. We could say, okay, in region A, we had the problem B and we did C, and these are examples of how to solve problems. But I think to have this kind of overview of basic strategies, and then of course now thinking about which strategy should be followed in my particular region, or perhaps a combination of them. No, again, there will not be a single answer of what to do, what is the best solution to a problem, and often it's a mix. No, you can of course provide new resources and at the same time use water resources more efficiently, and perhaps also thinking about another allocation of water resources. So they're not mutually exclusive. But I can share, perhaps I have also for the other approach that of course we could follow when we are talking about measures. No, think about the previous figure, measures or interventions. Again, here you have different terms. You can talk about projects at the end, if it is let's say a concrete activity, but how to reach the goals. For that, I can share another publication that goes through different examples, from around the world, where you can see, okay, which solution was chosen and how successful was it. Yeah, so that is, of course, this is now coping with water scarcity. So if you think about the other big strategy or the problem, it's too dirty water. Now, again, we could say, what kind of solution are we looking at? So here, perhaps we are, if you go back to this system view, then you say, okay, you can target different approaches. So now one would be perhaps to just prevent pollution. So that means you are protecting the source. So if you look at the source, and this I mentioned before, so before you can either say, okay, I take the source, whatever the quality is, and then I treat the water source. I treat the source water. But you can also, of course, protect the source, and then you can and you should still treat the water and before you supply it to the people or to the industries. But of course, if you look at the system at another point, this is where the wastewater is created. Here is another way of intervention. If you think about pollution as a holistic problem, no? Then you can also go to that point and say, okay, before I discharge water to the environment, I should treat it. And with that, I can protect the downstream users. So this is a simple system here, but downstream, there may be other users. Now here, it's an ecosystem in this view, but it's not only ecosystem, it's any kind of further user downstream that may be impacted. So I can choose the point of intervention, either protecting the source or treating the water before its use, or treating the effluent actually, or even treating the water once it's in the environment. So that's also in some places of the world this is happening, no? So that is these are different different options, no? But of course now, for example, here if you look at that point from the source to the treatment of the city, let's say, and if it's a city or industry, you know, let's say with the water supply part, and we are concerned with water quality, again, you would have different options. We could now zoom in and say, yeah, what are the different options I have? You know, of course, if it comes to treatment, you have many different technologies at hand, how to treat water. You can use perhaps more nature-based solutions like letting wetlands clean the water, but you can also have chemical-based solutions. Or you can have, for example, what we do here in Cologne. We have a combined supplier from natural groundwater. So of course, amount of groundwater that is recharged naturally, so that it's a sustainable solution. But in addition, we also take water that is infiltrating from the river to the nearby groundwater. That is so-called bank filtration, no? Or bank infiltration. That is water that is abstracted right next to the river. And you can imagine that next to the river, there's a kind of continuous supply of water. If you abstract water next to a river, there is always recharged. But it's already a better quality than the river. And here in Cologne and in the Rhine River, you may know or have heard that there was a time when it was very polluted, no? And that was in the 1960s and 70s when the industry was booming, and chemical industry in particular is quite strong here in the Rhine. And the river was almost dead. No, it was contaminated extremely with all kinds of pollutants, because at that time also the awareness for environment was very low. But still, let's say the water that you pump from nearby the river had an acceptable quality. No, acceptable is not enough. No, but it was better, much better than the river quality. So what did they do? They actually took that water from the bank filtration and transported it a couple of kilometers to an area where you have meadows, no? And there they infiltrated it to the natural meadows, and then it infiltrated to the ground, joining the same groundwater resource that we also use to supply Cologne. So it's a combined, let's say we use groundwater, but it's coming from the natural recharge, but also coming from this bank filtration water that is treated by natural systems. That means it is infiltrated to the ground, recharging the natural aquifer, and then used. The quality is so good that we don't need any treatment. So that means here this part, or we actually use treatment, but it's only basically an additional sand filter. And there's a standby, there is an activated carbon filter, but that is basically not necessary. It's only for the case that some chemicals we don't know or we don't detect that they are absorbed. You know? But it's actually the quality of the groundwater is so good that you don't need any additional treatment. You know? So you let nature treat. The similar example existed. It's not happening anymore, but in the past, and it worked quite fine. The whole wastewater of Berlin actually was, of course, it was pre-treated. It's not the raw wastewater, but after that, after this pre-treatment, it was also distributed over meadows in the vicinity of Berlin, and letting nature clean that water and infiltrate it to the ground. So that's also some solution that would work. Of course, you have to know the hydrogeology quite well. You have to know the system, how it behaves. You have to monitor very well, but these are solutions that work. So again, I would say in this loop, and the same applies to drainage from irrigation systems. Also here we have to see often drainage from irrigation systems has a high level of especially nitrogen compounds, because these are the most soluble ones. Fertilizers are N, P, and K, nitrogen, phosphorus, and potassium, usually, and then some other elements, but in very little concentration. So K is usually not a problem. It's a salt that even it's usually much lower concentrated than. That means potassium is much lower concentrated than sodium, and sodium, potassium are not really dangerous in that sense. Phosphorus is usually retained by the soil, so it's not reaching the environment in so high quantities, but it could also in certain parts of the world be a problem. But nitrogen is having compounds like ammonium, but in particular nitrate, NO3, that is easily leaving the agricultural environment, leaching often to the ground, but if you have a drainage system, ultimately reaching the drainage and then downstream rivers or the groundwater. So again, you could say, okay, let's treat that water, but this is not really feasible. So you have to find agricultural practices that are using nitrogen more efficiently. Again, of course, having a double positive effect. If the farmer is using nitrogen more efficiently, at the end he or she can pay less for fertilizers instead of letting the fertilizer at the end drain. You would drain the fertilizer that you buy for a high price. So having not only water use efficiency but also nutrient efficiency in the field is a big win for the farmer and for the environment. So here it makes complete sense to really think about solutions that are preventing the pollution. It will have a high economic return. Yeah, so these are examples perhaps for the other. So again, strategies and yeah, hopefully you see how the system approach can help here. Just having in mind how not only the water is, let's say, connecting everything, but also how different users and I always put here also people, in this figure, because at the end, involving the right institutions, the right representatives is required in order to find the best solution following a system approach. Yeah, and perhaps now we could go, that is a classical system. So you could zoom in now, and it's following the system approach would say water treatment is a black box. We had that topic. So for the watershed management, the whole city is a black box. For the urban water management, if you say I'm managing urban water resources, first of all, the water treatment would be a black box, just water going in and then treating it and clean water coming out. But of course, you could now go deeper and deeper into the different components of the treatment process, and here you would then identify different elements that all of them you could optimize, by this is drinking water treatment until you leave it until it is leaving the system for water supply. Or you could think about urban management in a way that is now the too much water. No, if you think about floods, and only the component where the seal surface in the city is the cause for floods, then you may want to convert the whole city into a sponge. No, so this is the sponge city approach, which is one out of many terms we are using. In order to show that we are just factoring in natural systems into the city. We are looking at lakes or ponds in the city. We look at urban forest. We look at wetlands in the urban region or adjacent to it. We perhaps look at green roofs. We look at bioretention. That means any space in the city that could retain water, and these are, let's say, existing green spaces that are managed in a different way, or could be additional green spaces. You could think about permeable pavements. You could think about roof gardens even. So a green roof could be just something growing on a roof, but you could convert a roof to a garden. No? If you think about a house having, for example, 100 square meter roof, imagine if you have an intensive agriculture, how much can you produce with 100 square meters? It's a lot. No, it's in terms of vegetables and perhaps other supplies, it can have a significant impact, positive impact even on that family. But it would have here, first of all, the sponge effect. That means it is a different way of finding a solution now to the problem of floods, and at the same time having hundreds of co-benefits. That means we are thinking about solutions in a kind of system way. This would be the system, the city, and that is actually having many other positive effects, and in the sum, these effects are much better than to construct flood protection or to build big retention tanks in the city out of concrete, which are costly, which are also ugly, and which are creating a completely different environment. What are other co-benefits? If you have a lot of green spaces in a city, the city will be cooler. No, I think you know that very well. If you go inside a green park on a hot day, you feel quite comfortable. It's not only the shade; it's just the evaporative effect as well. So there are, let's say, different ways to solve problems if we are using this system approach. And by the way, now sponge city is a term you may have come across. It's actually a term coined in China. They built a lot of new cities, and they realized that this way of building a city is much more effective. But you will find the same ideas also packaged in other terms. For example, again, from Australia, you would find the term water-sensitive urban design, or in the United States, already in the 1990s, it was known under low-impact development, LID, which is, or sustainable stormwater systems. It's another way, but it's then focusing really on the way we are using rainwater in the city. And then you have, of course, nowadays it's all termed as nature-based solutions or green-blue infrastructure. So this is another term used for that. Ecosystem services or ecosystem-based management. So many terms, but at the end, I want to emphasize again, it's not you should not be confused by the many terminologies we use, but by the way we look at things to be solved. And this is the message here, is that if you have too much water, you can think about reducing the flow by interventions in any part of the space. That means anywhere where rain is falling down, you could think about an intervention, and often doing that in accordance with the principles of nature, because nature or an ecosystem as a combination of the plants growing there in a soil can provide the most effective attenuation of the flow peak. So that would be the main message going across here, and having all the benefits. And now I mentioned the benefits of cooling the city, so that is quite obvious. The other benefit is more green spaces means more biodiversity. So you may feel more comfortable in a city with many birds than without any bird. Of course, we have to be careful. Also, there could be other side effects like having more mosquitoes. If you think about a lot of wetlands in the city, and you would also attract mosquitoes or other insects that you don't want. So that is, I'm not trying to idealize it or to say, okay, this is the perfect solution. Or it's not an ideological thing to say working with nature, that's it. But at the end, you have to make a list in the sense of multi-criteria decision making, saying this is what it costs. This is also the cost in using more land. Land is expensive, so some of the nature-based solutions require land area that has a cost. And on the other hand, these are the benefits. And then engage people who have a stake and then take a decision in that way of multi-criteria decision making. Of course, since you are researchers, you can do it in a quantitative way, in a stringent way, and also in a convincing way, even using economics and finance considerations. Yeah, now let me look at the time. It's already 10. Yeah, that is what I thought. There are more slides. I will share the slides. Now we could talk about planning and management. We can revisit some of the aspects we've discussed before. You may have traditional approaches, bottom up, top down. So here we are suggesting to really have a system planning in the best sense. That means looking at the whole water resource system, looking at all the people involved, not having neither a top-down nor a bottom-up approach, but a realistic approach. And I also once more, and this is now for the I think at least third time I'm saying it, don't be confused by all the words that you find to describe certain things. Some of you may have heard about theory of change. So that is, nowadays, if you write proposals, you not only have to refer to the SDGs, you have to refer, let's say, to, of course, the goals you want to reach, but also you have to sometimes use a certain vocabulary. So theory of change is also there. So some NGOs or some institutions require you to describe things in a certain way. But if you look at it, if you now look at terminologies like theory of change, you will find that it's the same approach that I introduced in the beginning. I don't call it something. I just said, okay, we are basically we are starting with a certain task. We have to work in a certain system, in a certain boundary, in a certain region. Then we are understanding where are we and what do we want to reach. That is the vision. Then you are defining the objectives or goals. That is what we call the water security in all its different aspects. And then you define activities. That means interventions or measures that are basically transported through a plan, but at the end you are implementing these activities and you're monitoring it. So it's again the same kind of view that you can apply to solving problems, and now it's called theory of change. And you may find other, also the log frame is similar. It is just a way to structure things in the sense of, okay, I'm trying to reach the following, and now reaching things can be expressed as goals or objectives. Sometimes you also have the vocabulary of outcomes, or first output, reaching to a certain outcome and then to an impact. It's again different words saying the same things. And you are, let's say, you have to know what you want to reach, that you have to know your objectives. You have to define them in an adequate way together with the right people and the right institutions, and then thinking about how to reach them. And for that, you have always alternatives. There's not the one best solution, but you have to find, hopefully, a very good solution. And for that, you have to scan through the options. Of course, you have to know the options. And for that, you are trained now, you become trained water resources managers, IWM experts, and so you have to know the alternatives, and then compare them. And in knowing the alternatives, there are catalogs available. I can also share them with you if you like. For example, for the topic I mentioned about urban water management, especially these nature-based solutions or green solutions, there are so many catalogs that tell you what you could do, and they describe the pros and cons of each intervention. Yeah, okay, so then the rest is additional information about blue water, green water, if I'm using it more efficiently, but these are just variations of the same approach, I would say. Green infrastructure we covered. Okay, for today, that's it. I would say thank you very much for your attention. I would also say that with this, I am stopped